So thank you everyone for being here, and it's my pleasure to moderate this panel where we want to look about what are the ambitions of the OEMs and how thermoplastic materials can answer to some of those ambitions. It was very interesting, introductions before, because basically we have seen how the exciting time aerospace we are living now. I think it's the combination of the perfect moment of the high demand on commercial aviation while preparing the next generation of aircrafts, together with the defense sector with new solutions coming on, the democratization of space, and also new disruptive technologies that opens new spaces, like, for example, urban air mobility. So on this panel, we are very lucky to have 3 representatives from OEM, so the 2 leading aircraft manufacturers and an engine manufacturer. So with us, we have Susana Carballo. Susana is the Vice President of Airframe Engineering at Airbus, an aerospace engineer by training, so she holds an executive MBA and a master's degree in aerospace business. And she has held different leadership positions across both Airbus Commercial and Airbus Defense and Space. And now she also serves as Vice President of the Airbus Women's Network. We also have with us Carlos Bello, who is an experienced senior composite engineer at Boeing, with more than 20 years of experience in manufacturing engineering and development in aerospace industry, mainly focused on composite materials, both thermoset and thermoplastics. So he currently works at Boeing Technology and Innovation with the focus on industrialization of composite material processes and improvement of production efficiency. And also Paco Beltrán, so he's the Associate Director of Engineering for ITP, Aero, Externals and EBUs. So he is an aerospace engineer from Polytechnic University of Madrid and brings more than 30 years of experience in different aero engine programs, including Trent 500, 1000, Pratt & Whitney GTFs. And he served in different roles, including chief engineer, chief design engineer, as well other roles as MRO certification engineer. So many thanks for the 3 of you to participate. I want to start with the first question that I want to make, same question for the 3 of you. And I would like to ask you, what are the key challenges you see today in the future of aerospace, commercial, defense, space, nowadays? So how are the challenges and where do you see the sector is going on the future?
Okay, well, I will start if my colleagues... Okay, we have been discussing during the whole morning the beautiful moment we are living in aerospace industry. And as Ricardo has mentioned, we are in the 4th revolution of aviation. So we are all lucky to be participating in this revolution. For me, the challenges in commercial aircraft, because today I will focus on commercial aircraft, I will tell you something about the defense and space, but really for commercial aircraft, we have seen that the main challenges that we have, and I will link with the event that we have today that is based on materials and thermoplastics, for me is the production rate, obviously, and the second one, main challenge that we have in front of us, sustainability. And let me tell you, and I will come back to some words mentioned by Ricardo. We have an incredible growth in air traffic at world level, okay? The estimations are around 3.5% every year in the next years, and this means that we will need to produce, design, and build the aircraft manufacturers, my colleagues in Boeing, we in Airbus, and others that are coming strong to the market, and of course the engine makers. We have to produce 43,000 aircraft. This was the figure said by Ricardo. So it's huge. And in order to do that, we have to increase dramatically the rate that we have nowadays. And this is a big, big challenge for the material, the carbon fiber material. We will expand a bit later. But for me, this is a big, big challenge we have in front of us. And the second big challenge is sustainability. How to merge this question of increased air traffic with the sustainability demand. You know that we, the aerospace industry, have an agreement altogether to achieve the net zero emissions in 2050. 2050 is very, very close, because developments in aerospace are very long, because it's a lot of development, a lot of people around the development. So this means that we have to increase a lot the sustainability of the materials, the way how we produce the aircraft, and the way we operate the aircraft. This is key, and for me, these are the two main challenges that we have in the aerospace industry. To add some challenges that I see in the defense market, for example, in the defense market, in terms of materials, they have different requirements, because the defense is much more specific. We have very different areas in the defense. So we have from the drones that we need very cheap materials, because really in the drone, the airframe is just there to carry the systems, to very exclusive materials that are having very incredible properties in low observability or survivability. So we have very different challenges in the defense sector. So today I will focus in the commercial one.
Thank you, Susana. And now we move to another OEM, in this case of engines, Paco. So I'm asking you, what are the challenges that you see as an engine manufacturer on the future?
So, well, from the propulsion view of the challenge, we fully agree with our colleagues from Airbus and Boeing regarding the sustainability and production rates. Well, sustainability regarding emissions, we as an engine, we are the main contributor for emissions, so we are having a lot of focus on this. And because of this, we have to provide a solution. This is our challenge, and this is what the current engines industry is getting a big focus. Now there is different approaches that needs to be really established. There is sustainable aviation fuels. There is also hydrogen. There is also hybrid electric, pure electric. So there are many propulsion alternatives that needs to be arranged in the different sectors of the overall industry, mostly commercial, but also including defense. So all this happening at the same moment is really a very rare scenario and a lucky time to be an engineer in this industry. So, but at the same time, it's a challenge, because all of this has to be well consolidated in a individual solution for each sector. Also important, this new solution regarding the urban air mobility. This is also getting new demands from the propulsion, and at the same time there are also many different architectures that is now running at the same time, like demonstrators, like new space to be covered in a industrial way. So all of this at the same time needs to be supported by certification rules, because now current certification rules is well established from traditional propulsion, aero engines, all of that. So these new methodologies of propulsions is not covered by now for the certification rules. So all of this has to be run in parallel Because at the end, what we pursue as a demand from the society is the safety that we already have from the current aviation. So all this new technology of propulsion is to get the same level of safety that we already have. There is no other way to do it. And this means that all certification rules needs to accomplish and needs to be written down just to support all these new architectures. And well, in the short term and in the commercial side is the new single aisle platform. It's really a challenge. It's going to be happening shortly. And this combined with the sustainability plus the additional requirements in efficiency, noise, there are a lot of set of very hard requirements for this single aisle new platform. This is really a challenge that we have to face. As we on ATP are currently a risk and revenue partner in the Pratt & Whitney GTF, so we know this space of the single aisle with all the deliveries that Susana was mentioning is really a challenge. We need to be able to deliver at scale. It is something new, and with the level of deliveries of the single aisle plus the growth, plus the new requirements, is a big challenge.
Thank you very much, Paco. I think we saw a lot of, let's say, challenges that are going in the direction of material and structures, for example, high rates, costs, sustainability, of course, and also certification challenges. No? So that, among other challenges, but I summarized these as the main ones related to materials. And my main question is, it's fine to have challenges, especially as engineers, we like challenges. My question is now about how can we solve those challenges, no? And more specifically, how thermoplastic materials do you think, in your opinion, can contribute to find a solution to those challenges? So I would like to start with you, Susana. What's your opinion about the thermoplastic materials?
Okay. Let me start not with thermoplastic, but the carbon fiber materials in general, okay? Because as Paco has mentioned, the engine is the main contributor to the emissions, but it's also true that the airframe is very important, and we need light structures and light materials because all the weight that we put on air needs more energy to propulse. So we need lighter materials, and in this sense, carbon fiber materials are key to obtain this. The big aircraft that we have currently flying that are more based in carbon fiber are the Boeing 787 and the Airbus A350. In the A350, we have 52% of the structure in carbon fiber. That is great, is huge. And our customers love this aircraft. We cannot go in a different direction. And why our customers love this aircraft? Because they are more easy to maintain. We build the aircraft, we design the aircraft, we as engineers design the brilliant aircraft, but are their customers who have to keep the aircraft flying. And they make money by flying our aircraft. So the less maintenance we apply to the aircraft, the best, because it's more time for them to fly. So with carbon fiber materials, we are reducing corrosion, so we can space the big maintenance checks that the aircraft needs. So carbon fiber material is a big challenge. But what happens with carbon fiber materials? And then we enter in this rate production. Obviously, we need to advance in this rate production and cost, because you have mentioned it. We cannot go a step back in the affordability of aviation. And we cannot have materials that are super expensive, that we make the aircraft or the aviation is not affordable for the majority of the people. So we cannot go a step back on this. So carbon fiber needs, or we have a big challenge on this because of this. rate and also cost. In thermoplastic has very good advantages against prepreg, for example, or dry fiber. And one of them, obviously, is sustainability. Ernesto has mentioned it in the opening of the session. We can, with the thermoplastic material, we are able to arrive to an end of life of the aircraft, separate the different materials in order to facilitate recyclability of the material. But, and also have another advantages that are mechanical advantages, also mentioned by Ernesto, I think at the beginning, the welding. It's a big, big advantage. We have to stimulate the in-situ consolidation because it can mean also a big step forward in technology. And also, of course, there are mechanical properties of the thermoplastics that are a good advantage. And but I want to finish this part of my speech now is what an expert in Airbus says, that there is not a material better than other or a process better than other. We have to be enough clever, and the engineers, we need to take the best out of engineering and manufacturing engineering together. We need to consider the best material with the best process for an intended application. And this is the challenge and the motivation of engineers really in the next years.
Many thanks, Susana. I guess engines have different requirements. So my question to you, Paco, it's whether you see also some opportunities on thermoplastic materials on engines.
Yeah, well, really, thermoplastic will increase efficiency on engines, on turbines, basically from weight and aerodynamics. So is providing this additional level of improvement into the aero engines, considering that what we call cold temperature is high temperature in composite. So here the key is to the higher temperature range that thermoplastic is providing. That's the key. So currently we have in engines we have some composites, but it's in a small scope. With thermoplastic, this scope can be broadened and can be open to getting this benefit of composite regarding aerodynamics, weights, etc., in a bigger scope on the engine. And for this, the maximum temperature is a key for application on aero engines. Also, one of the benefits that will provide will be the manufacturing and the capability to integrate complex parts into a much industrial process. That is really important because at the end, once that we have to combine different design requirements into a individual piece, the capability to do it in an industrial approach is really a need for what we face, this increase on growth and deliveries. For this, we really need to move on into a more industrial approach for this type of materials. The capability to make a much complex part, an assembly, by the individual sub-assemblies that can be joined together, not joined, but similar to weld, is really a one piece. That capability that thermoplastic is providing, I think is really good. It's a key, it's opening the space for aero engines. At the same time, reparability. This is really important because the challenge that we face regarding deliveries, the capability to make small repairs during the manufacturing process is key to protect deliveries. Other way, we have to scrap and make it a really no cost-effective solution. So now with the reparability feature of the thermoplastic, really open this cost-effective approach and protecting at the same time deliveries, because minor deviation during manufacturing can be corrected during the process. So that's something that is much harder to do with the traditional composites. So in this sense, I will say that these three benefits that thermoplastic is giving is really interesting in order to incorporate this thermoplastic into the engines.
Many thanks. We could have been discussing all the morning. We don't have time for more in this panel. I would like to summarize that we have placed here a number of opportunities, basically to solve what the aerospace needs, and there are some opportunities that come from thermoplastics. We need obviously to tackle high-rate production, but making it at an effective cost. How we look into recyclability, sustainability also in production, and how we tackle these challenges. Temperature, if we want to use it in the future for engines, and taking into account about repairability, maintenance, and how that is important for the future of the aircraft. So I think we are, as we said before, we are in the perfect moment for aviation now. Probably in this panel we placed a lot of questions, and hopefully during the rest of the day you will be able to have as well some answers. So I want to thank you again, Susana, Carlos, and Paco, for this panel. And with this, I hand over for the next sessions of the day. Many thanks.